Now we're going to be working with rates and unit costs, and these are very useful things that you can use. I mean, we do use a lot of this in everyday life, so it can be very useful. So we talked about ratios, and a rate is a type of a ratio used to compare different types of quantities, like miles to gallons or dollars to hours. And there's some keywords that are helpful. The word per, 117 miles per 2 hours. That's this rate if you wrote it like a ratio. For $12 for 3 pounds, you could write it as a ratio like this. In 400 meters in 43 and 5/10 seconds. On 270 miles on 12 gallons of gas. So writing rates in lowest terms, this is similar to writing ratios in lowest terms, except we'll have different units, and so the units will not cancel out. They'll be left. So we're going to write each rate in lowest terms or simplest form. We know what that is. We're going to divide the numerator and denominator by the same number. In one region, there are approximately 640 trees on 12 acres. So let's simplify that. I'm thinking we can probably, I don't know, divide that by we can divide these both by 4. So we would have 160 trees on, 3 acres? This would be in simplest form. You see, the units don't cancel out like they did with the first ratios that we look at. Latanya drove 138 miles on 6 gallons of gas. So again, our units will stay. We can divide both of those by 6. And we would actually have 23 miles on 1 gallon of gas. So that would be simplified. After a cold front, the temperature changed like negative 40 degrees Fahrenheit in 4 hours. So we can write our rate like this. And now we can simplify the numbers because the temperature and the hours, the degrees, are not going to cancel out. So we can divide both of these by 4. So we can say that the temperature dropped 10 degrees Fahrenheit per hour. Now, unit rates, these would both be examples of unit rates because they have a denominator of 1. They're called a unit rate. The number 1 is often omitted in the denominator. So if we have this, we say 23 miles per gallon rather than in 1 gallon. 52 feet in a second would be 52 feet per second. $15 per hour for 1 hour would be $15 per hour. So if you want to convert a rate to a unit rate, in other words, a rate that has a denominator of 1, you can divide the numerator by the denominator and maintain the units of measurement. So we'll write each rate as a unit rate and round to 3 decimal places if necessary. So a health club charges $125 for 20 visits. So how many dollars is that for 1 visit? That would be our unit rate. So I'll just go to my calculator and I'll divide 125 by 20. And I'm getting $6.25 per visit. This is so simple with a calculator. In 1960, Wilma Rudolph was a track star. She won the women's 200-meter run in 24 seconds. Find her speed in meters per second. So we have 200 meters in 24 seconds. So what we want to find out is how many meters in 1 second. How many per second. So we're going to divide 200 by 24. And I am getting this number. So it said to round to 3 decimal places. So we're going to round to here. We look at the next one and it is less than 5. So this is going to be 8 333 thousandths of a meter in a second. The next one is a baseball player, and we're going to find his batting average. So a baseball player, I think that's supposed to be the word has 149 hits in 403 at-bats. Find the player's batting average. Batting average is defined as the number of hits per the number of at-bats. So he has 149 hits, 403 times at-bat. If you walk, it doesn't count. So what we want to know, we're going to figure out how many hits for one at-bat. So we're going to divide 149 by 403. And this is the number that I'm getting. And that tells me, since that fills my screen, that tells me it probably goes on. So we want to round this to 3 decimal places. We look at the next digit and it's a 7. So we're going to go up. Instead of 369 thousandths, we're going to have 370. And as most of you know, that would be read as a batting average of 370. That would be quite good. Anybody that hits over 300, that's a good batting average. Now we're going to do that same thing to find the unit cost or the unit price. It's the cost for 1 unit of something. 1 banana, 1 pound, whatever. At the grocery store, for example, you might purchase meat for $3.79 a pound. The unit cost is useful in day-to-day life when we compare prices. So if we had $4.19 for 46 ounces of apple juice, this is the quotient. So it would be that much per ounce, or they rounded it to 9 1/10 cents per ounce. If there was a jug that had 64 ounces and it was $4.89, we could figure out how much 1 ounce would cost. And it's actually 7 6/10 cents per ounce. So if you wanted to compare unit prices, this would be the cheaper one, wouldn't it, than this one? So we have $3.55 for 32 ounces. And if we figure that, we find out that it is a little over 11 cents per ounce. So this would be the most expensive. And a lot of times in grocery stores, you'll see this unit cost on the little price sticker on the shelf. It'll tell you how much so that you don't have to do the math there. Very kind of them, I guess. So let's do a couple of these. If we want to find out the unit price, in other words, what 1 ounce would cost for this sports drink, we're going to round it to the nearest thousandth of $1. So when we have $1, we're going to be looking for thousandths, which, you know, for cents, it would look like this. It's going to be 1/10 of a cent or 1,000th of $1. So for the quotient, we're going to divide $3.25 divided by 64. I use my calculator, and we'll find out with the dollar signs, it would be per ounce. So if we want to round that, if we want to round it to the hundredths of $1, the 7 says go up, so it's going to be 51 thousandths of $1. Or we could write that as 5 1/10 cents per ounce. Okay, let's look at the next one. We have $9.59 divided by 160. I'll do that on my calculator. And what I'm getting on my calculator, 599,375. And that's that much per ounce. And if we want to round it to 3 decimal places, we look at the next digit and it's a 9, so we're going to go up. So it's going to be 60 thousandths of $1, or 6 cents per ounce. And let's look at the last one. We have $1.95 divided by 32. And I'm getting this on my calculator. If we round it to 3 decimal places, we look at the next place and it's a 9. So we're going to go up to this is per ounce. So we would have that many. That's in dollars, and if we want to make it in cents per ounce. So really, this is the cheapest. This is the most expensive. And this is the middleman. And often this will be written on that sticker on the shelf. Next time you go to the grocery store, you might look, and it'll tell you how much per ounce different things are. You can compare brands, you can compare sizes of packages like we're doing here. Generally speaking, the larger the package, the cheaper it is, the unit price is cheaper. Not always, but for the most part it is. Different brands will vary, but you'll mostly find that.